So I'm going to show you two more queries before we move on to something else. So let's say we want to find where some variable, let's say parsed underscore query, got modified. So I can do something like Redhawk query / assignment / refer variable name equals parsed query of 0 Redhawk. And you can see that these are where parsed query got modified. The 0 at the end indicates that the refer variable node is the 0th child of the assignment, which means the left value. So I could do this also in another way, just to drive the point across. I could do Redhawk query / assignment @ and in this @ code block I could have any lambda function in Python. The default node is given the name n, so I could write here n.lvalue.name equals parsed query, and I could run it on Redhawk, and you can see that this gives you the same results as the previous example. As a final example, I'm going to let's say you wanted to find functions that do not conform with your coding standard. Let's say your coding standard tells you that every function's first letter should be a capital letter or a camel case. So let's try and find all functions that are not camel case. So the way you do this is you'd say Redhawk query / define function, and you'd have a code block in there saying @n.name of 0 is not equal to n.name of 0.upper, and you could run this on Redhawk and you get a list of functions that were not camel case. As you can see, it's either functions like main or setup and tear down, which have to be that way because that's how unit test and nose test work. So I'm going to show you the selector syntax that Redhawk supports. It's a more verbose version of the jQuery syntax. It's far more powerful than the XPath syntax and allows you to combine intermediate results using the Python programming language. So I'm first going to drop myself into a prompt with predefined imports and variables by using Redhawk prompt. So as you can see, trees is the list of all trees in the project. So since I gave Redhawk as the project, tree is a list of all the trees that the Redhawk project has. All the source files passed into trees. So let's say I wanted to find this, a list of global functions that are recursive, right? So the way I do this is first define a global function selector, select global functions, define a call function selector, so that defines function calls, and then I check if the name was the same for both of them. So let's go ahead and do this. So I'm going to do global function selector is a node of type function definition that has a parent which is a node of type module, right? And I can run the global function selector on the list of trees by simply calling it on the list of trees. And as you can see, global functions is a list of trees of defined function. Now I'm going to define a call function selector that's a refer variable because we wanted to refer to the function being called in the call function. So it's a refer variable whose parent is a call function. And if we run this call function selector on the list of global functions using the apply method, because we need both the parent and the child, we get a list of refer variables and define function pairs. Now all we need for recursive function is that the name of the refer variable which was inside the call function is the same as the name of the defined function. So we can write this out using a list comprehension. So recursive functions is a set of all f for caller for callee caller in the result if c.name equals f.name, and we can print this out really neatly using the print context in file function. So I'm just going to map it onto the list of recursive functions, and you can see that yeah, there are a list of recursive functions that come up like expand list and so on. So